All right, here we go. I think a really interesting problem here. You get to bring in a lot of your previous math knowledge and get to apply it here. So here we go. Water flows into a conical tank that is 100 centimeters wide and 250 centimeters deep. So, all right, so it's a height of 250 centimeters, and it is 100 centimeters wide. Um, and now water's coming in at a rate of, so water coming in at a rate of 40 cubic centimeters per second. And now that water's kind of filling up as it goes, filling higher and higher and higher. Um, but it's the volume of the water, it says find the volume of the water, volume V of the water in the tank as a function of the height of the water. So however high up the water is at a given time, that height is how we want to figure out the volume of our kind of little pool of water here. So here we go. Um, we know that at the very top, the radius here, if it's 100 centimeters wide, the radius at the very top is 50 centimeters. Okay, that's the radius of the top. But as I'm going to draw that line down, and that's our height. That's the 250 centimeters. There is some point where the water, we'll draw this part in blue, the height of the water maybe is only part way up, um, and its radius is going to be smaller. So we'll call that, the radius of the water we'll call R, and the height of the water we'll call H. So we're not talking about the height of the cone because the height of the cone is specific. It's 250. It's not changing. As the water keeps coming in, the height of the cone remains constant. And also the radius of the cone, again, remains constant as well. It's 50 centimeters. So with all those pieces of information, let's kind of start going here. So we are told that, or sorry, we know from geometry or just from our past math experience, or maybe you just forgot, but that 1/3 times the area of the base, so the area of the circle at top, and actually we're doing this volume for the volume of water, so the area of the little water base right here, and that is going to be, sorry, the area of that base times the height, so our height h, again, times 1/3 is the volume. That's the volume of the water. Now, as we did in one of the problems earlier with volume, we're going to replace that area of the base with, so 1/3 times, instead of the area of base, let's actually write what it is, and it's pi times r squared, and then that times the height. Now, we're supposed to write this as a function of the height h. So the variable we need to replace this time is going to be r. Now, as we try to figure out where can we get r, we've got to come back over, and we've got the full height of the triangle, or the full height of the cone, and the full width of the cone. But notice we've got a couple of similar triangles here. And here's our right angle. Here's our other right angle. And we're going to set up a proportion. So depending on how you want to set that up, either you might want to set it up as, well, the radius of the water divided by the height of the water. That's going to be equal to the radius of the cone divided by the height of the cone, so 250. And you could set it up a few different ways. I think the filled out notes have it the radius of the cone divided by the radius of the water, so it has 50 over r is equal to the height of the cone, 250 over the height of the water. And that one works as well. But here we go. So the radius of the water divided by the height of the water is equal to the radius of the cone divided by the height of the cone. And now this here will simplify down to 1/5. So let's go ahead and rewrite that. The radius divided by the height is equal to 1/5. And I want to get radius by itself, so we're going to multiply, not 1/2, sorry, 1/5. So I'm going to multiply both sides by height. And we get, lastly, that radius is equal to, let's change color, radius is equal to 1/5, keep it right, 1/2, 1/5 times the height. So now we know what R is, and we can substitute it in for R up here. And so we've got volume, going to slide it to the right a little bit, is equal to 1/3 times pi. And now instead of R squared, going to plug in 1/5 h squared, and then that times the height. And now we can see in here that we've got just h's. We're done as far as other variables are concerned. Now we just need to clean it up. And hopefully you're seeing as we go through this, hey, this is a function in here. I found the radius as a function of h. And hey, in here we've got the area of the base. That was a function of, that was the area of the base, which was a function of the radius. And hey, now we're going to get volume all as a function of h. So I'm hoping that you're seeing that these things are really are building together. With that being all said, let's kind of simplify it through here. We've got volume equals 1/3 times pi. Now 1/5 h squared is going to be, actually go ahead and we'll just go and put it right here. That's going to be 1/25. Let's have h on top. So or 1/25 h squared. Never mind, we'll keep it to the side. Times h. All right, continuing on. We've got volume is equal to, and so as we multiply this out, our pi is in our numerator, our h squared is in our numerator, this h over here is in the numerator, so we end up with pi times h squared times h is h cubed. In our denominator we have 3 and, give it a little different shape, 3 times 25, so over 75. We've got our volume. Actually, I should go back. Now that we've back up here, we got it all in terms of h. We have volume v of h, v of h, and v of h. And we didn't write it out specifically, but you could have had back here, by the way, you could have had volume as a function of, or a relation of, I would have to take a bit more just to look through that, but I think as a function of radius and height. That's how we've got it defined right here. But then we substitute out the radius, and it was just a function of the height. And so that's where we were trying to get to. We've got now the volume as a function of height. So we did what we were setting out to do. That's part one. And actually, I'm going to go ahead and pause here, but we'll continue on in next video of, now remember, we're supposed to find the volume of the water as a function of time. We'll come right back and do that in just a moment.